I'm going to start by putting out two things, which you should be accustomed to. So this is a passport, the one you used to, or you probably have one if you travel around. This is an ID card, issued by the same country. Now, how much do you know about this? Because you actually carry it pretty often, but how much do you know about what's actually in it? Now, how many of you knows that there's a chip in this, an electronic chip? Do you know about this? Yeah. So this actually is the case for that one too. And now the one thing they share, the one thing in common is that they follow a standard which is set by the United Nations. Actually, the agency that does this, I'm going to get right to it, is called the ICAO, so the International Civil Aviation Organization. So this started with passport because that was the main use case. Since they regulate aviation, that's what they care about. People traveling around, they use their passport. National ID is not the thing. But it was picked up mostly by EU countries, but some other countries are doing it to also add it in national IDs. So with this, you have a pretty potent source of trust, you would say, for identity that you can use directly with anything that's capable of reading an NFC-enabled chip, which includes phones. Your phones are capable of doing NFC, and you use that every day when you use Apple Pay and stuff like this. So use NFC all the time, and this you can use with your identity cards or passport as well. So the main idea here, and I'm going to start by a demo to showcase how that works, is that you got the ZKPassport app here, right there. I'm going to start with my passport. So what you do is that on the front page of your passport, the passport details, you have those two lines, which are called the machine readable zone, or MRZ. And this contains information that allows you to authenticate with the chip and also decipher the information because it's end-to-end encrypted between the device reading and the chip to avoid eavesdropping. So you read it locally using a simple OCR that gets that information, and once you have it, you scan it, and the process of reading the chip happens in a few seconds. You need to be stable though. I need to not move too much. It should be easier if you generally lay down on the table, but with enough expertise, you should be able to do it like this. And once you scan it, it will straight away start with the generation of the proofs. So we use Noir, so pure Noir circuits. There's no Aztec for now here. We'll probably integrate with Aztec later on, but this is pure Noir. So this is an example of what you can do with Noir, as just to make circuits. We generate proofs over the two signatures. So what happens essentially is that this data on your passport or your ID card, which is your name, your birth date, all kind of information about you, are signed by your country, or the country that issued that ID at least. So they have those public key that you can fetch somewhere. The ICAO do provide some. The country sometimes will provide it directly on their website. This is the case with France or Germany. And they only them know that private key that they use to sign this data. But you have the public key, and that's all you need to be able to check it against the data that's been signed. And all this, we do it within a zero-knowledge proof. So we keep all those inputs private. The only thing that's going to be public is that whatever is signed, your passport, is in a registry of all the country's certificates or public keys that we are aware of, and that we've been able to prove that's within that, and that's the only thing that's revealed. So you don't even actually reveal which country you actually sign your passport, unless you want to reveal it. So those three proofs, we need to generate three proofs for that, because here, as this is shown on the website, you got two certificates. Anyone is familiar with SSL certificates? So you got this idea of trust chain. So you got a root certificate, which is made by some trusted authority that's generally encoded in your browser. They know that they can trust it. As long as that goes back to that root certificate from that trusted authority, then it's trustworthy. And then you got some intermediary certificate in the middle, and the final one that actually signs the data. In this case, there's only two. The root certificate are the states, and an intermediary certificate that's embedded in the chip. So you can get directly that certificate, which is called the document signer certificate, from the chip. And the rest, you need to find it in some registry. So we call that the CSC, or country signing certificate. And once you verify those two signatures, then you've been able to verify that that indeed has been signed by the issuing state, and that the data you're using then to disclose information about yourself has been signed. So you can reveal whatever you want. And that's where you do the disclose proof. For example, disclosing that you're over 18, disclosing your official name, your nationality, or that you're within the group of countries, like for example, you're EU citizen without revealing from which country. That's the kind of use case you can have. And so now I have those three base proofs generated. It only took, it's in the background, you don't see it. It took about 8 seconds, generally, on that phone. And I can show with the demo that we have, I think this is, well actually, let me go open, there we go. So we got a demo, they can try it directly from the website. I'm gonna show proof of age. So essentially, I'm gonna scan it with my phone. It's going to open a little pop-up on the app that is going to show you exactly what information you want that the website is asking. So you can always be sure that they're not asking for more than what they're pretending to. And so you click on confirm. You see, Face ID shows up here because essentially it will prevent anyone that's not the phone's owner to use your ID. So it protects you against that. And the proof has been sent back directly to the website. And you can actually look into the console to see that everything went correctly, but I don't think it's very visible. Oh, there you can actually see it. So here you have like what we call the unique identifier. So every ID, you can get an identifier that will be the same for the same ID. It doesn't reveal anything about the person or the ID, but you know it will be the same for the same person. And that can be a base for proof of personhood or at least proof of valid ID. So you can use that to prevent cyber attacks or spams on your website. So you can be sure that someone is not trying to use a bot or something. I mean, a regular person would probably not have more than 3 or 4 IDs on themselves. And you can get, here it says that it's been verified because in the background, and this is using the SDK, we'll show you how you can use it. The SDK will verify the proof for you. So Zay has shown before how to verify a proof using the BB command line. Here it's using like Aztec.js, BBJS more specifically, to verify those proofs in JavaScript because the SDK is a JavaScript SDK essentially. So all this is verified for you. It also verified the public inputs because there's some logic going on that needs to be verified too. So this idea of like public inputs that's very like visible to the verifier. Here, for example, you can see that there's 4 subproofs that have been generated. They are linked together with commitments. And so those public inputs, those contain the commitments, and we need to check those commitments so that the proof, we know they are linked to each other. As you can see them here, they are showing up. And that's the final compare age proof. All right, and just to show similar process, but with an ID card. So on Passport it's not so visible, but the ID card you can actually see the chip here. It's a bit more sensitive than Passport, so you have to be a bit more careful with ID cards. But the principle is the same. You have the MRZ at the back. It's 3 lines instead of 2, but it's capable of recognizing that 2, and then you proceed with the scanning. And now you scan an ID card instead of a passport. Both of them works. Both of them generate proofs. So, any questions so far? No? All right. I'm going to start by showing, so the SDK, there's some quick docs available. If you go on the website ZKPassport.id, you will get directly the link to the docs. So this is pretty simple to install. It's like an npm package. You run npm install at ZKPassport/SDK, and then you can follow along. But I've got an example already ready to use on GitHub. I'm going to show the QR code, if you can scan it and copy it to your computer. But otherwise, the link is on ZKPassport GitHub and ZKPassport ZK example. And so this integrates already the SDK. and so you can get started pretty quickly. I'm going to leave you a few seconds to get to it. Right, everybody got a chance to scan the QR code?
Yes, we can clone it,
Yeah, you can clone the repo and get started. It's a simple Next.js repo, and you can get started by running npm run dev. First you need to run npm install to get the whole package, and then npm run dev to run the server locally on your local host, and you can get started. But one thing you will need though is you will need the mobile app. So for that, you can go directly to ZKPassport.id. There's a download link. It will be easier if you have an iPhone. If you have an Android, it's possible, but it's going to be a little bit more of a process. So, for context, ZKPassport mobile app is in open beta on iOS. So it's pretty easy. You just need the link. Android is closed beta, so you need an invitation from us. So we would need your email. So it's a bit more of a process. So that's why. So I can show the QR code here for iOS. So this is this one. It will take you to test flight and you can download the app and try with your own ID if you got one on yourself. It's like regarding the ID supported, if you have a very recent Portuguese ID, Carta de Cidadão, issued probably, I think, 2022.
June 23.
2023, the latest one, because the Portuguese ID up until recently was using their own standard for like the chip, but now has been using the international standard because in EU they set out a new directive that all EU countries should use that same standard for all national IDs, same as they did with passport like a few years back. So if you have like a very recent Portuguese ID that will work, French ID, it works since 2021. All European passport supports that, most passport in the world as well. So with those kind of ID, you can use it. If your ID doesn't have a chip, then it won't support it, and we won't try to support it because you can't get the same guarantee. You can't get the same guarantee with the cryptographic signatures that you will get from a chip. Everyone got to scan it? All right, so I'm going to show quickly how that looks.
So my phone is there.
Oh yeah. So here, like this simple app, essentially. So this is everyone familiar with React? Yeah. Okay, cool. It's the most common front-end framework, so it's always like an easy starter. So here, for example, we're gonna unveil disclose the full name, whether you're a EU citizen, whether you're over 18 or not, and get the unique identifier. So the way it works, here you're going to use like useRef because you just need to initialize it once to initialize ZKPassport. So you initialize ZKPassport SDK, but after importing it here from the SDK here. So you pass it your domain name. So technically here, on the browser, you don't need that because it will automatically detect it in the background. But if you use it in Node.js, you will need to specify it because there's no host name, there's no window location object in Node.js. So this SDK is meant to be working both in the browser and in Node.js. So once you have initializing it, you can start to build your request. So you need to specify your app name. For example, here that would be ZKPassport. Then your logo as well, so that will show up in the app, the access request pop-up that the user will see, your purpose, which the user will also see, and a scope. So the idea of having a scope is essentially you can target a specific use case list. Let's say that you want to have proof to be scoped to, I want to be doing a poll on that given subject. So I'm going to scope it to that. So that's something you don't have to specify it, but it can be useful. And by default, the proof is always scoped to your domain name. So essentially the unique identifier I talked about earlier is depending on the scope. And it will be the same for the same ID and the same scope. So if a user uses his passport on a different website, it will have a different unique identifier. So there's no cross kind of like checking, so there's not too much leak of privacy here. So each website will get a different unique identifier, but for your website, it's always going to be the same. And so once you have this, the query builder, you can start to do your query. So here, for example, you want to know that his nationality is within EU. So we got some constant, like EU countries. It's essentially a list of countries. So you're gonna ask the user to disclose that he is within the EU, that he should disclose his full name. So essentially that will include, so that's an important distinction. First name is gonna be just your first name without you give your secondary given names or your middle names. I think this is primarily important in Portugal, where you have like a lot of secondary given names, so it's only going to be your first one. Last name is going to be your last name, and the full name is going to be everything. So first name, secondary given names, middle names, and the full name. This is going to be greater than or equal age, so 18 or plus. This is disclosing your document type, so it could be a passport, could be an ID card, or it could be even a residence permit. Because in EU now, residence permits are also electronic. So you could technically do a proof of residence, although the support is not as broad. And so once you have done this, you call done, and that returns the URL, which you can use to encode into a QR code or directly a button if the website is consulted directly on mobile, which will redirect to the mobile app of ZKPassport. If the user doesn't have the mobile app, it will redirect the user directly to our website with a page that will guide him or her to download the app. And
so here the disclose means that the user is disclosing this information?
yeah, so disclose is like disclosing specific information. The other are like more like comparison thing. So like this is an inclusion proof. Greater than, so like this is for numerical values like dates or like age. So this is greater than or equal. You could also have like less than or equal that you can use with the birth date or expiry, or less than for age. So you could say that you 18, but you also at 25 at most. Like say for example, you want like a young people discount. Like that's something you can do. That's something you can do as well. You also have like range operator. So you can check like age, like say between 18 and 25. That would be an alternative way of doing it. What else? You have like equal. You have exclusion proof. So for example, let's say that you want the user to be from the EU, but you want specifically to say that, actually, I don't want them to be from Italy or Spain. So Italy and Spain will not be part. The user should be from the EU, but not from Italy or Spain. And actually, when you specify a country, you can specify directly the country's name, and behind the scene, we will handle it to like proper formatting of the country codes. Because what we expect is like 3 letters country code, but you can directly put, and you will have like autocomplete from the strong typing we have of the different country you can put inside the request.
So the user just scan this passport, and that test will run in the background? Or?
So what will happen is that once the user scan so I can show the process again. So essentially the app, that's the app here running. So if I scan the QR code, you will see that I scanned it. So now the website knows that the request has been received on my phone. So now I see the pop-up with all the information that's requested. When I click on confirm, proofs are being received now by the web app, and now finally the result is being shown. So the SDK will receive those proofs, will take them, extract the public inputs, check the public inputs, that they are all correct, that it is indeed part of the registry that we are aware of in terms of the certificates, the commitments all check out, and then verify the proof with BBJS, like Barotenburg JS, so that the proof has verified. And once all that is done, then the verified true will tell you that indeed has been verified. If it's verified false, then you should not trust it. It means there's something wrong that happened and you should not trust the result. If verified is true, then you can trust it. Sometime it may happen. I've actually tried to cheat the system once. So like I've inserted like a different certificate in the certificate chain that would not correspond to the other. So the commitment was different and the SDK picked it up. So you can always like be sure that it's going to be correct. And this is the unique identifier as well, which is scoped to the website, specific to the domain and the website specifically. So I'm an EU citizen, yes, I'm over 18, and that's my full name. Actually, I don't have any secondary given names for some reason. No?
I have a question. Like, for each one of these assertions, does it like create a program with the different assertions, or is that like different proofs? One proof that of your name, one proof of your citizenship, another proof of the age. Are they different proofs, or one proof, only one proof that proves all of it?
So you're gonna have different proofs depending on the type of information you ask. So you always have those three base proofs, like the proofs checking the first signature, which is like the signature of the root certificate or the intermediary certificate. The second base proof, which is the signature of the data by the intermediary certificate. The third base proof, which is the data integrity check, so checking that the data essentially, which is hashed, and the hash is the final message that's signed. All this does come to the same message that's being signed. So all those base proofs, they're always going to be there. And then you're going to have the disclosure proofs. You're at least going to have one, but you can have more than one. So you can have like 4, 5, 6 proofs. And here in this case, so full name is a disclose. So just disclose the bytes from the MRZ. EU citizenship is another type of proof. It's inclusion proofs in nationality. So that's a separate circuit. So that's 2 disclosure proofs. 18, that's an age circuit. So that's another proof. So that's 3 disclosure proofs. And yeah, that's it. Like that one has for this to work, this has like 3 base proof, 3 disclosure proofs, so that's a total of 6 proofs.
So another question. For the EU citizenship, that's where the Merkle tree proof goes, right? Because you're proving that you're part of your citizenship is within a group of countries, but not within the other one.
Actually, the only instance where we use the Merkle tree is for the certificates, because like there's a lot of them. So we do make an inclusion proof using a Merkle tree of all the certificates, but for the country, it's not a Merkle tree. It's like a much more simple array. You can like, because like it's going to be at most 200 countries. Because that's about the number of like official countries there are in the world. So the Merkle tree was not necessary. But for certificates it is. And actually I can show, it's going to be here. On verified.zkpassport.id/certificates, you can see all the certificates that we are aware of, the root certificates of the state. So for example, if I search Portugal, so those are the root certificates of Portugal we are aware of. We don't see much here. Let's see do I have like a dark mode? No, I don't think so. But yeah, so you can see the public key and some other information such as the exponents. One thing I probably didn't mention so far. So IDs, they use 2 types of signature algorithms, it's RSA and ECDSA. So those are the 2, and then they have different parameters. So we needed to support all those. They got different parameters. RSA is like, it's a bit more simple. ECDSA was a bit more complex because there's a lot of different curves. But like for example, Portugal, they only use RSA for their root certificates, but the ID though, the intermediary certificate, they use ECDSA. France only use RSA. Germany, they use ECDSA all the way, but they use brainpool and that. The different countries can use whatever they want for the signature algorithm, as long as it's RSA or ECDSA. So far we have about 775 certificates, but that's not everything. There's more. Some countries have like they make it harder to find their certificates.
Are they not available by? There is not like an API for iCal that you just can grab all of them?
So yeah, so if you go on iCal and you go here, so you got the iCal masters list. So the iCal provides some country certificate they are aware of, and you can download right here. So this is actually part of the source we use, but there's actually, surprisingly, German roots, what's the master list? Surprisingly, the Germans are more efficient than this. It's like, they have their own master list here, the Germans, and it actually has more certificates than the iCal one. So it has, it has like around, and it gets updated pretty often actually, because I updated they actually updated like 3 days ago. So it's actually a pretty good source of for like all the CSC we want. We can directly get it as a zip, and then we need to parse it, and then we add it to our registry. You also have the Netherlands that provide a master list, but it's a bit less complete. Any questions so far? Has anyone been able to play around with the SDK or like the sample app?
Not yet.
Not yet. I'm going to show one thing. So another thing we provide as well is this web verifier. So for example here, I'm going to do full name, nationality, generate the QR code. And what this one does is that you can download the proof as like a simple JSON. And then once you have it, so I need to go in my downloads. So like it's a JSON, you have the verifier here, you drop it, and it verifies and shows the information. So this, we actually used it with a few companies whose names shall remain anonymous for due diligence. So this acts as a proof of like a simple KYC if you want. It's not full KYC because for full KYC you would need AML and CTF and all the stuff, at least in financial terms. But for simple due diligence, that's something you could use. So like showing your full name, nationality, and birth date is essentially generally what you need in this case. So that's the tool we provide for that use case.
And ZKPassport includes most major developed countries' passport.
Yeah. So actually, there's like some other projects working on this, and I like to use there. We haven't built something like this before. Oh, they actually removed it. Never mind. They had this nice map. I don't know if they took it down. Ah, damn. Too bad. They used to have these maps. I'm gonna show mine on map then. I like their design. So you got other projects working on Passport. You got Open Passport. You got like Rarimo. Rarimo is like, they're pretty good at voting. That's not something we generally focus on. Voting, especially in the context of voting at the state level. Because whenever you go at the state level, you probably go in cryptography, like you're gonna face the highest threat model you can ever get, because you're facing state actors. And like state actors are probably you can consider a state actor to have like unlimited resources. And when you have like unlimited resources, it's hard to fight against them, especially some state in particular. I won't say their name. It's like, but it's very hard to fight them. So like in this context, you need to be very, very good about security and stuff. So Rarimo, they've been building solution for voting in Georgia, in Russia, and some state where there's some issues regarding democracy sometimes.
But simple, like you could have a token sale excluding U.S. citizens.
Yeah,
and a VPN wouldn't get around it. You need to have an ID that was in your registry.
Yeah, you would need. Yeah, you would need you would need to prove that you have an ID that's not from the US in order to participate in the token sale. That would be stronger than using a VPN that obviously you can easily get. I think so. If we go on, so this is our repo where we will have all our circuits written in noir. You can actually see in source that noir, and you will have all our circuits here. For example, this is the inclusion proof for the country, so that's noir code. That checks the inclusion. So if you want, as an answer to your question, this is like an array of country, and they're using constraint code to get the index and then constrain it after. So for this case, it's like much easier. And for exclusion proofs, we use like another system, which is like using like sums of character bytes, and we just like look at the order again. So that's something in noir, it's the kind of pattern you can do, is like you use unconstrained code and then you can constrain later. You have to be careful about how you do that because you don't want to unconstrain too much and not constrain enough. In ZK, that's going to be the most common mistake to have like under constrained code. So when you do, for example, let's say you want a common operation you will do unconstrained will be division. So you do the division in unconstrained, and then you constrain that it is indeed a valid by doing a multiplication, that it is indeed the inverse of whatever you wanted to divide. So that way the division, which is actually a very expensive operation, can be done constrained, but you're always sure that's the correct result by constraining with the simple multiplication after. So yeah, like this idea is similar. We do like a more expensive operation in constrained code here, and then we constrain it after by doing proper constrained code here. But what I wanted to show is this map here. So this is the map of the countries that issue electronic passports. So that's most of the world. Well, the countries that do not issue electronic passport, they should be visible in gray, but like it doesn't show, like it shows like white, like in existence. It's a bit weird on the screen, but it should be gray. But like noticeably, you will see that India is not on the list. India does, I mean, if you look at a certificate registry, though, you will find that India is in the list. You do have some certificate from India, you have one. But the thing is, India, as far as I know, for now, at least, they only use it for diplomatic passports, not regular passport. But I think they may eventually switch, also provide to regular passport. You also have like a bunch of African countries that supports it. All of Europe, all of North America, most of Asia, and most of South America as well. So it's about 150 countries, 160. So in EU, you got national IDs as well. So it's a pretty good coverage.
And we call that biometric?
Yeah, you call that biometric as well. So biometric or electronic passport, e-passport, they got several names for it.
It's the same thing.
Yeah. So actually, has any one of you been to an airport? Automated gate. So this is the same principle that we were producing with the mobile app, essentially. So when you go at the electronic gate, they ask you to open your passport, to like open it on the detail page, slide it in, so they can read the MRZ, decode the information that you need to communicate with the chip. They communicate with the chip, they get your information. They have like a list of certificates they trust, they verify it against that, and then they extract your photo, and then they ask you to make the face recognition, check it and get your passport photo, and they let you through. So this is the same mechanism, but on the mobile app instead, and in ZK.
And they say that they delete your photo after that.
Well,
we have a disclosure that they say, we'll just check and then delete it.
That I don't know. I'm not sure I'm not sure they do, but
Yeah, I'm not sure they do, but that's what they say.
that's what they say. Yeah.
That raises this question that I have is when I scan my passport onto your app, how do I know that somehow, and sorry if it's a stupid question, but how do I know that you don't get the information or that you don't keep it?
So we're going to open source our app soon when we're going to publicly release it on the App Store. So that's something you can do. You can check the code. Another thing you can do, but you would need probably a bit more expertise, is you could technically check all the packets of information that's essentially sent by the app. And you would see that at no point the passport data is sent over like to us, to our servers or anything. So the passport data is really kept locally encrypted on your phone. So on iPhone, we directly use like Apple services that they have like their own encryption mechanism. On Android, we do the encryption manually because they don't have like proper system for that. But that's why you need to use Face ID actually. You need to use Face ID to access your passport data because it's encrypted with your secure element. Like, yeah. And so if you ever want more information on the SDK, you can always go to docs.zkpassport.id. You have some example here, for example, how to do age verification, nationalities, check your citizenship, check sanction list countries. You also have like the session countries as part of the constant. Residency, so if, for example, if you wanted to do residency, you would need to check that document is a residence permit and the country that issued it. The country of issuance, not the country of nationality, because that's what matters here. And for example, here you could say that he's resident of France, or you could do like an inclusion proof of EU to say that he's a resident of the EU. So that works with some ID, proof of personhood. So regarding proof of personhood, so Zay mentioned World ID before. So the thing about proof of personhood is like it's a rather difficult problem if you want absolute perfection, in the sense of like one person, one ID. So like that's what World is trying to do. They have their orb that's scanned to your iris. The iris is really that one thing that's unique to you. It's more unique than your fingerprint, which is going to be the same if you have a twin. So that is not the case because there's actually random patterns in the generation of your iris patterns that not going to be the same between twins. So this is truly unique. So that really could serve as a good thing for proof of personhood. Now, in the case of passport, you can have, like, as I do right now, have two different IDs. So I could pretend to be two persons, two people. So what you can do with the ZKPassport is more like a proof of valid ID, which you can kind of use as like somewhat of a proof of personhood in the sense that you reduce Sybil attack surface to only a few IDs, and a person will probably not have more than 3 or 4 at most IDs. So you can have like one ID, one account. So it's like a stronger Sybil resistance. So by doing that, you can just do this. You don't specify anything, you just do done. You don't disclose any information, you just want the unique identifier. That's the only thing you care about. And that's your proof of like valid ID that you need. And then later on, you can use that on, for example, we have a more complete example here. You have like a client-side implementation when you do what the example showed before. You do the whole process, you scan the QR code, and finally you get the result back here in the on-result callback with the verified and the results. And you send that back to a server, to a server endpoint with the proofs and the query result. And on the server side, you get that back here from the request body, and you use ZKPassport again to verify this in Node.js on the server side. With the proofs and the query results, it will send you back the verified Boolean and unique identifier again. So you need to check that it is verified, otherwise you cannot trust it. Then the identifier is defined, and once you have that, you can use that, for example, to register a user. You can use it as a unique ID, along with his email and all the information, if you want to collect his nationality, for example. And that way you have like a more spam, Sybil resistant account creation in a more Web 2 flows. Regarding Web 3 flow, so we're still working on it to have like the verify on-chain and the logic in place to have the proof verified on-chain. What we plan to do, because now you have like a bunch of different proofs, we want to gather them into a single proof using recursive proofs. So essentially, the idea of recursive proofs is that you have a proof that verifies another proof. And so with this, we would have like a circuit that would verify all the proofs that we generate and would generate a single proof of all the sub-proofs that we have, all of 4 or 5 circuits. So you have like one final proof that you could send on chain and verify. Because if you would have to verify all the proofs on chain, that would be too expensive. So that's something we need to work on. There's some thought to be have on how we should structure that.
Like for like a count abstraction or something, so that you would have to sign a proof that you would, instead of a seed phrase.
Well, you could use that for account abstraction. You could use that. Passport in this case is mostly going to be used as a social recovery mechanism, because for actually signing stuff, you would need like an active like signature, not a passive one, because like this is a static signature from the state. Some IDs are capable of signing stuff because they have a private key in it actually that can sign stuff. But those, for example, the French IDs, they don't provide the ability to sign arbitrary data. You don't have control over that. But some IDs do provide that ability, but the support is not as broad, so unfortunately you can't really use it that much.
If I get a new passport and my previous passport, do these have different signatures, I guess, because the issue date is different?
Yeah.
They're 2 separate documents?
They're 2 separate documents, different data, so different signature.
In the case of account abstraction, maybe you could just remove one recovery and add another one if you lose your passport or something. As long as you still have access to your account, you can always like change the recovery. So that's why I was saying that seed phrases are like done.
So yeah, we actually, so we have ZKPassport, but we're also building this wallet on Aztec, which is gonna integrate ZKPassport directly, especially with the mobile version. So that's something definitely we're gonna use. Well, you could have this for a social recovery method, but like we're gonna use this as an identity and compliance to power the compliance tool we're gonna need in the context of like having a fully private wallet, like using the privacy of Aztec. So we need some level of compliance, and that can be provided more client side with tools like ZKPassport. But I believe it's going to be more and more common to have those kind of tools using different kind of like wallets applications. I mean, ZKPassport is open source and non-profit, so anyone can use our tool. So yeah, definitely that will be interesting to see what people can do with that.
Just to give you like a quick project if you wanted to play with it. And like if you don't do it, I'm gonna do it like in a hackathon or something because it's gonna be fun. It's like to have like a bot on the Discord server that will give you like some kind of role if you are like if you are a real person, or even for a certain country or something. So that's a cool way of just showing off, having some fun, and saying this person, that's the real blue check that Twitter should have. Of course, it will leave out everyone that doesn't have an electronic passport, but it's still cool as an example for Discord or for Twitter or something, just having this nice thing saying, I'm a real human. I have used ZKPassport to verify that.
Or any airdrop kind of thing. Right?
Airdrop is another example. Yeah, it could airdrop to people, which is really interesting. You could airdrop to everyone from one country.
Well, another important use case that's been like touted in many countries is age gating, which is becoming more and more common as countries are starting to ask adult content website or other type of website that are age restricted to do proper verification using proper methods, while still keeping the privacy, well, for most states at least, while still keeping the privacy of their users. I've actually talked to the French government on several occasions on that matter, because they enacted a law regarding age gating on adult content website that's actually enforced now. They were very mindful about privacy. They knew the possible consequences of like asking user that much information, and they also knew all the pitfall of that, because like a major pitfall that they are aware of and they're conveniently ignoring. I mean, I don't think there's much to do about this, is that because those restrictions are per country, you need to detect from which country the user is visiting that website, whether to apply that restriction. And that way, a simple way of cheating where you're from, because that is generally using IP addresses, is using a VPN. So you can always use a VPN in another country to not be asked to check your information, even though you're visiting from the country where the restriction applies. And I think that's what most people are going to do eventually. But like as it becomes larger and becomes more common across countries, VPNs may be forced to do verification of their own. Actually, during the discussion I had with the government, they were like, yeah, we should probably ask VPNs to do edge verification on their side as well. I don't know how viable it is, but well, we'll see how it goes. I think that pretty much does it. If you could actually theoretically use those proofs into Noir circuits as well. You have the proofs, you have the public inputs. Now we didn't specify in the docs yet how to do that because we're kind of waiting to have like the single recursive proof that's easier to integrate, both in an Aztec and a Noir context or EVM context. But that's something you can do as well. So you could like build logic on top of ZKPassport in Noir circuits, and that after that too in Aztec, which we're gonna use for our wallet as well. Any questions so far?
How do you fund this, since it's open source, grants for Aztec or?
I don't think, do you have a grant?
Well,
I don't think you have.
We had grants to some occasion because we had to build up a lot of tooling to make this work, notably mobile proving tooling, because the proof are directly generated on mobile. So there's a bit of a challenge in doing that, especially around RAM consumption, like memory consumption. Like phones are a little bit more limited. For example, let's say on your computer, when you use a lot of memory, what happens is that something that's called the swap is used. Essentially, it uses a bit of your hard disk to kind of like delay a little bit of the RAM into actual hard disk. So the mobile phones don't do that. So essentially what happens is on your mobile phone, when you consume too much RAMs, your app will just be killed. And they're pretty severe about this. In general, when you have like, let's say 8 gig of RAM on the phone, you're gonna be able to use about half of it at most. So 4 gig of RAM, and sometimes it's even lower. And after that, they're just gonna kill the app. So you have to be very mindful about how much RAM you consume on a mobile phone. Otherwise, the experience is gonna be pretty bad if it crashes all the time. So we had to do this natively. So we had to like create a whole tooling to make it work. That whole tooling is also made, actually let me show it, is also open source. So other people in the Aztec or Noir ecosystem can use it. So this is built on top of Noir RS. Noir RS, which is essentially like a tooling in Rust that allows you to generate proofs or execute, like solve like circuits in Noir, and you have like you can directly like talk to Brandenburg to generate those proofs. And this is optimized to be used on mobiles, where mobile architectures like Android and iOS. So this is what we use behind the scenes on ZKPassport to generate those proofs. Now we have a bit of wrapping around this. We have something called SWAR. And essentially what SWAR does is that SWAR is like specifically a Swift library that communicates with Noir RS to generate those proofs on iOS. And we got an equivalent Noir Android for Android to generate those proofs on Android. And all this is brought back to React Native because the app is built in React Native. So all this tooling is publicly available, so people can use it if they want to build their own app, mobile app, using Noir to generate proofs on mobile. So that's one of the things we got grants for. ZKPassport is now making profits because it's non-profit, there's no business model, but we have like that wallet on Aztec, which is called codename Obsidian with an O. That's a code name. And That is what is going to be more the business model around. ZKPassport will be kept as an open source non-profit because this is truly a public good. This is like, identity is a public good. This is hard to create a business model around, and it should probably not be so. Many people will have a use for it. It will become like a primary tool, especially in the age of AI, on the internet. So that's something that people should be building as a public good. Like the wallet on Aztec, that's something we can definitely generate a business model with. Yeah.
Yeah. One thing I forgot to mention is like Aztec has a ton of like hacker houses, what we call app sprints. So basically ways you can start building and get some support, either financial or just mentoring. And we do that quite often. For example, it's going to be one of these app sprints, which is like, I guess, a 2-week sprint to build applications like real life applications. Some of them are in person, some of them are not. So I think the best here is just to be part of just to follow the Twitter for Aztec and Noir or Discord and just be aware because this happens quite frequently. Yeah, also like sponsoring hackathons and stuff like that. So yeah, our goal is like, obviously will not be your business model, but we also want you to not be bankrupt because you're trying to use Noir.
So yeah, I think that's pretty much it. In general, the SDK has been made to be pretty easy to use from a Web 2 perspective. That's the primary target we had first, and then we'll extend to Web 3 as I mentioned before. So yeah, if you have any more questions, I'm open.
Well done.
What?
It's really good. Well done.
Yeah, thank you.
Cool. Guess we still have some time, so you can stick around or just leave. I don't know.
Just thinking out loud, would there be a situation where imagine you have a country which is super cool, very nice, let's say Switzerland, right?
Yeah.
Just an example. And they have this registry of citizens, and somehow if you query them, you ask, is this person more than 18 years old? And they would answer yes, but somehow you don't need to reveal the identity of the person. Would that somehow circumvent the use of ZK knowledge proof?
So, some country have alternative like method to do this. Yeah, like specific like attributes disclosure. I think Germany has one. Their own kind of like proprietary stuff with their ID cards. It doesn't work using zero knowledge. It's more like an interactive process. But the issue with that is that you need to get authorization to use it from the German government or German authorities. So it's a bit more permission system. Here's like, it's a bit more permissionless and it's like international. So it's a standard you can use in every country. You don't have to rely on the specific country standards or authorization mechanism, which is a bit cumbersome.